Alright, this is section 6.5, equations containing radicals. So we're going to take what we've learned in the past about solving equations, what we learned in chapter 5 about extraneous roots, and apply them to radicals. How do we solve equations containing radicals? So we first must define a radical equation. An equation which contains a radical with a variable in the radicand, which of course is the number inside the radical, is a radical equation. First, you'll want to isolate the radical term on one side. So you can have a radical term, you might have more than one. You're going to isolate one of them on one side of the equation. Second, you're going to square, or in some cases cube, both sides of the equation, and you're going to solve for the variable. And this will make sense when we go over an example. The third and final step, once you solve it, make sure you check your answers in the original equation for extraneous roots. What's going to happen is you're going to get some solutions. Once you plug them back into the original equation, they're not going to work. So you're going to have to discard those roots and keep the ones that check out when you go back and check your answer. So you're going to have to check your answer always when you're doing these equations. Again, isolate the radical term on one side, move everything except for the radical term to one side of the equation. Then you're going to square both sides and then check your answers for extraneous roots. So we start with example 1. We have radical 2t minus 1 minus 3 equals 0. So the first step is to isolate the radical. So let's move the 3 over to the right side, and you get radical 2t minus 1 equals 3. Step 2 is to square both sides. So the square of radical 2t minus 1 is simply 2t minus 1. 3 squared is 9. Now you solve for t. So this is no different than what you did in Algebra 1. Add 1 to both sides, divide both sides by 2, you get t is 5. Finally, you'll need to check for extraneous roots. So you'll plug 5 back into the original equation to see if it works. So there it is, and you'll see that radical 9 minus 3 does equal 0, so the solution is 5. Again, isolate the radical to one side, square both sides, and then solve for t. Finally, once you get your solutions, make sure you check all of them into the original equation to see if they work. If they work, you can keep them. If they don't work, throw them away. Here's example 2. Go ahead and try this one yourself, and don't forget to check your answer when you're done. So we square both sides. We get 2x minus 1 equals 49, and you'll get x equals 25. Now you'll go back and plug 25 back into the original equation to see if it works. And lo and behold, it does. Radical 49 does equal radical 7, so the answer is 25. Don't forget to write your answers in a solution set when you solve for x. Number 3, we have root 7x minus 12 equals x. So again, this is something that I think you can do on your own. Attempt this one and then check your answer when you're finished. So you square both sides, you get 7x minus 12 equals x squared. You're going to have to do some factoring. So let's move all the terms to the right side so we get x squared minus 7x plus 12 equals 0. Now we factor. Factor x minus 3 times x minus 4 equals 0. So our possible solutions are 3 and 4. Now we have to go back and check both answers to see if they work. So we plug in 3 into the original equation. So we get 7 times 3 minus 12. Does that equal 3? Radical 9 does equal 3. Let's go check the 4. The 4 plugged in, and we get radical 16 does equal 4. So we can keep both answers. Again, isolate the radical to one side. It's already been done for you. Square both sides and then solve for x. Plug in all your x's into the original equation and then check your answers. Radical x minus 10 equals radical 2x. Go ahead and try to solve this one and check your answers when you're finished. Squaring both sides, we get x minus 10 equals 2x. You get x equals negative 10. Let's plug that in to the original equation. And you get negative 10 minus negative 10, negative 10 minus 10 equals radical negative 20. Well, that looks the same, But we have a problem. Radical negative 20 is not a real number. Therefore, there is no real solution to this problem. So just because they look the same here, the problem is you can't have a non-real number equaling any other non-real number, and this is a non-real number anyway, so you can't make it work. Let's go to number 5. Radical 20 minus x equals x. Try this one as well, and check your answers when you're ready. So you're going to have to factor a little bit. You get x squared plus x minus 20 equals 0. You can place that as x plus 5, x minus 4 equals 0. So x is either negative 5 or 4. Don't forget you now have to check your answers for extraneous roots. So let's plug in negative 5. 20 minus negative 5 is 25. The square root of 25 is not equal to negative 5. Remember, when you take a square root of a number, it is only the positive or principal root, which is 5. So these two are not the same. Let's check the 4. So 20 minus 4 is that 4? Yes, the square root of 16 is 4. So our only solution is 4. So this is our first case of an extraneous root. What happens is sometimes by squaring both sides of the equation, you don't end up with the same equation that you started with. So you're going to have to make sure you check the roots to see if they work in the original equation. In this case, radical 25 is not equal to negative 5. It is only equal to 5. Alright, so now we have two roots in the equation, and this is going to take a multi-step approach. So the first step is the same. You're going to isolate one of the square roots. So let's move the radical x plus 6 to the right side here. And now you have radical 2x minus 2 equals what you have on the right. Just like before, you will square both sides. Now when you square the right side, treat this as a binomial, where radical x plus 6 is like a, and plus 1 is like b. So it's a squared, which is x plus 6, plus 2ab. The a again is radical x plus 6, that goes there. B is 1, so we don't have to write it down, plus b squared, which is 1. So again, when you square both sides and you have a square root or radical on one side, treat the entire term, radical x minus 6, as one term for the purpose of squaring. So this is a squared, a is radical x plus 6. Alright, let's continue. Well, now look what we have. We have another radical, so again we have to do it again. So isolate the radical, and now let's square both sides. So now you have x squared minus 18x plus 81 equals 4 times x plus 6. So now we solve for x. You're going to have to factor, and you get x is 19 or 3. Alright, so again, so far, when you have two radicals in the original equation, isolate one of them and square both sides. You'll eliminate one of the radicals, and then you have to do the process over again. Isolate the last radical, square both sides. Now, of course, we have to check our answers, so let's check out 3 first. You plug in 3, you get radical 4 minus radical 9. Does that equal 1? And the answer is no. So we have to throw out the 3. Let's check 19. So 19 gets plugged in. We get radical 36 minus radical 35. That indeed is 1. So our only solution to number 6 is 19. So when you have these longer problems, make sure you're very careful when you square both sides, because that's where we can make some simple and careless mistakes. Alright, let's move on to example 7. Now we have, again, one radical, so we tend to like these better than the ones with 2. So go ahead and try this one and see what you get. Isolating the radical on the right side, you get 3x plus 3 equals radical 7 minus x. Now we'll square both sides, and you get 9x squared plus 18x plus 9 equals 7 minus x. Let's move everything over to the left side. We get that, and you're going to have to either use a box, the cross, or just use brute force. And eventually you'll get 9x plus 1 times x plus 2 equals 0. So our possible solutions are negative 1/9 and negative 2. Finally, we're going to have to check both answers again. Let's plug in the negative 1/9 first. Does that equation hold true? Let's plug it in. We have negative 1/3 on the left, 64 radical 64 over 9 minus 3, and indeed 8/3 minus 9/3 equals negative 1/3. So negative 1/9 checks out. Now let's check the other solution. We have a negative 2, And that doesn't work. 3 minus 3 is not negative 6, so our only solution is negative 1/9. This is why checking the answer is really important, because, again, when you square both sides, you no longer have the same equation because you've changed some of the zeros possibly. So, check your answers and make sure they work. Number 8, 2x equals radical 7x plus 2. Go ahead and try to solve with this one. Remember, follow the 3 steps, check your answers, and we'll see you when we're done. Alright, so you'll square both sides, and you will move everything over to one side, and then you will factor to get x minus 2 times 4x plus 1 equals 0. So your possible x's are either 2 or negative 1/4. Now let's go ahead and check our answers. Let's plug in 2 to see if they work into the original equation. So we have 4 equals radical 16. That is true. So we could keep the 2 as part of the answer. Now let's check the negative 1/4. So on the left side we have a negative 1/2. Let's plug this in here. We have the square root of negative 7/4 plus 8/4, which is 1/4. The square root of 1/4 is positive 1/2. So the negative 1/4 is not part of the solution. The only answer is 2. So when we do radical equations or equations with radicals, make sure you follow the 3 steps. Isolate a radical on one side, square both sides, solve for x, check your answers, and throw out any extraneous roots. If you have any other questions, please let me know. This ends the notes for section 6-5.